take them down and take them down and take them down, take them down, take them down and take them down and take them down. As you look, the whole room explode down and as you look, the whole room explode down and
there are several versions of Unix philosophy or Unix design principles. The one I chose was formulated by Mike Gunkars in '94, and his book was published in '95. It's called The Unix Philosophy. Well, I'm going to cover a subset of Unix philosophy principles. I chose the most relevant for us, Kontera. But before that, I would like to talk a little bit about who we are. In one sentence, Kontera is a technology company that analyzes what people write and read about on the internet, and we use it for various products, ranging from online advertisement to analytics. And here are some numbers. We have about 400 million API requests per day, and over 1 billion messages per day, about 1,000 nodes in 4 geographic locations, and we generate about 100 gigabytes of data per day, which, according to John Masser's presentation that he gave at GlueCon 2012, puts us in terms of API calls somewhere between Salesforce and eBay. You can find his presentation by searching for API Billionaires Clubs 2012. And the reason I'm bringing it up is not to brag about it, or maybe a little. The main reason I want to show that we are dealing with some real and complex problems. So before I get to the Unix philosophy principles, I want to set up some context. We have 4 major types of applications in our backend: services, pipelines, scheduled workers, and frontends. And I'll show what each type means. Services are basically stateless applications with synchronous APIs, JSON over HTTP. We scale it horizontally, and usually it's accessible via load balancer, either HAProxy or Unix. Most of the services are written in Clojure and Ruby. We have some in Scala and some in Java. And this is how a typical service looks like. There is a software, the application itself, and there is a model, which it can be local files or database or key value store. And this is this is an example of input and output of such a service. In this case, it's a phrase extraction service. So the input is a JSON object that has the content we want to analyze, and the types of named entities that we want to extract from this content. And the output is basically the result, the sentences, the phrases, with some metadata, the type of the phrase, part of speech tags, and stuff like that. The second type of the applications, we call it pipelines. And the pipelines, basically, it's a flow built from tiny applications that we call pipeline workers. The workers talk to each other asynchronously via message broker and using JSON messages. A pipeline worker is typically just one file written in Ruby. We built our own framework for that. And the pipeline is distributed across the whole data center. And each pipeline worker has multiple instances running on different machines. So here is a simplified pipeline example. This specific pipeline analyzes Twitter stream. Then the goal is to be able to say in real time what people think about certain products in terms of positive and negative mentions. And here we have 4 workers in this pipeline. So receive a tweet, we extract phrases using phrase extractor service, we detect sentiment, and then we just aggregate, some counts and key value store. Okay. So if you zoom in on a specific pipeline worker on this little box, you will see following. Worker receives messages from a mailbox and process. There can be many instances of specific worker. They all share the same mailbox. And once they process the message, depending on the type of the worker, it's either stored in key value store or in database, or it creates a new message with additional data and then adds some routing information and sends it to Exchange. Worker doesn't really care who sent the incoming message and who is the recipient of the outgoing message. The mailbox the mailbox can be bound to multiple exchanges, and the binding configuration is external to the server, to the worker. This approach has a very nice side effect. Since worker doesn't have to know who sent it a message and doesn't know anything about the recipients, it's much easier to test it in isolation. We can configure only relevant part of the pipeline on local machine, record some real production data, and then replay it on the local machine by sending messages to appropriate mailbox. The third type of the applications we have called the scheduled workers, which are essentially distributed cron. Each such worker is a singleton, meaning that only one instance can run at the same time in the system. And we use it for maintenance tasks like cleaning and archiving all data, service model updates, and report generation. And the fourth type is, we call it Frontends. Basically, it's all internal and external user interface applications, external APIs, diagnostic tools, and demo applications. So that's the context, and now we'll get to the Unix philosophy. So the first thing I want to talk about is called small is beautiful. And I'm not going to talk about why, I'm just talking about maybe a little bit at the end. I'm talking about how we do it. So we are choosing and creating tools that help making our programs smaller. For example, if we need to use JVM for some reason or some Java library, we will choose Clojure over Java because it will make our code smaller. And if we want to use Ruby, we will choose Sinatra over Rails where appropriate because it will be smaller. And also when we pick some third-party libraries, we will look at its dependencies and we will choose, of course, we are taking other things into consideration, but the dependencies and the size of the third-party library is very important for us. So here's some part of one of the workers example. The whole worker code is under 100 lines. It's one file, and it's very easy to read it. If you need to understand what it does, it's very easy to understand because it's very short. And this is another example from one of the service, from the phrase extraction service. Again, we use Clojure. It helped us to make the code smaller. The whole service code, is including tests, is about 350 lines. So the small is beautiful. Basically, smaller applications, the applications that have less code, it's proportional to the amount of bugs you will have in the application. It's also much easier to maintain. It's easier to combine with other applications. And it's easier to change and replace. If we want to rewrite it in some other language or use different library because it gives better results, it will be easier for us to change smaller application than to change something big. The next principle, called make each program do one thing well. Well, I actually don't really know whether this guy does well what he does, but I'm sure that most people will not do it well. So having one thing, when you develop a program, thinking about one thing allows us to focus on this thing, and which leads to faster development and simpler APIs. Simpler APIs, for us, it means that it's easier to understand the API, it's easier to test it, and it's easier to use it in different contexts. For example, the same service can be used in multiple workers, or the same worker can be reused in different pipelines. And even the output of a worker can be used in different pipelines. And making each program do one thing well also makes it have less dependencies, which means it's much easier to maintain this program, and it's easier to deploy it and to scale it. The next principle is build a prototype as soon as possible. So basically, we want to create an environment that simplifies experimenting with new services and pipelines, and also makes it easy to adopt new technologies. I'll give an example here. So this is the example from a few slides before, the Twitter analysis pipeline. So I've added two more things to make this example more complete. There is a front end, which allows to view the data that is aggregated by the pipeline. And there is a report generator, which is a scheduled worker that creates reports. Let's say we want to add one more thing to this pipeline, to this application. We want to see whether people say that certain entities are fun or boring. So we can add another service which can classify the text into three classes: neutral, fun, boring, like the previous service, neutral, positive, negative, which is essentially the same code, just different model. And we can also rename the worker that talked to the sentiment classifier. We can call it now detect sentiment and fun boring worker, for example. And it will call both services. There is one problem, though. We are disrupting the existing pipeline by changing one of the workers. It also violates one of the principles, do one thing well. Suddenly our worker does two things. And there is a better way, so we'll do it differently. It's still the same components. So we can add another worker and bind its mailbox to the same exchange to which the mailbox of detect sentiment is bound. So now detect sentiment and detect fun boring receive the same messages. And then we can call the new service and aggregate the data in key value store. So later, we can either change our front-end application or add another one, and change report generator or add another one to see the new data. And we did all this without disrupting existing flow. So the next principle, choose portability over efficiency. It probably meant a very different thing 20 years ago. It was more about being able to port your software to different hardware. And now it's less important because you basically can, most of the languages we use, it can run on different hardware. So now it's more about software and the protocols and the interfaces. So we chose JSON over binary formats, even though binary can be more efficient. We chose JSON for communication, talking to services, messages between workers. We chose HTTP instead of proprietary TCP. Again, the same thing, proprietary TCP might be more efficient, but we use HTTP. And we use compressed JSON files for archives, even though some binary data probably will take less space. Using text-based protocols allows us to use standard Unix utilities like curl, TCP dump, ngrep, and it's very useful. It's also much easier to integrate with third-party services. And even if you want to use Amazon EMR, for example, it's much easier to work with JSON files because you don't have to write your own deserializer. And the last principle I want to talk about is called make every program a filter. So the services and pipelines are essentially filters. It receives some data and it produces some data. Pipelines are actually filters that are built from other filters. Every worker is a filter. Keeping it in mind when we develop applications allows us to create new applications very quickly by combining these components in new ways. And it also enables us to extend our pipelines without disrupting existing flows. So summary, well, making small programs is not always easier. You have to think harder. You have to learn new things, even if you have 20 years of experience. And basically, it might look like we are trading one type of complexity for another. We have simpler components, but we have many of them, so it's more moving parts. And if we want to remain sane, we have to standardize APIs, create conventions, and centralize configuration, develop framework and tools, use continuous integration tool, we use Jenkins. We have to automate a lot of things. We have to automate deployment. We have developed deployment framework, and we use it for all our applications. And this framework can work with any build tool, assuming it can be scripted. The command line part of this framework called Chuck, and there is a rumor that it was named after Chuck Norris because it's not afraid of any build tools. And we do use a lot of them, Ant, SBT, Leiningen, SCONS. Monitoring, we monitor a lot of things, from basic stuff like average load, CPU, memory, disk, and network utilization, to application-specific stuff like queue sizes, number of running workers, service response times, error ratios, and other metrics. And, And we also have we have a lot of alerts, automated alerts. Eran Levy gave a nice presentation about our DevOps tools on Rails Israel last conference in November. You can find it by Googling Eran Levy Rails Israel 2012. Very nice presentation. So it looks like we do a lot of extra work. But the thing is, you have to have most of it anyway if you have more than few servers. And the rest of it is really nice thing too. So to summarize the summary, the benefit of this environment outweighed by far the cost. And this environment allows us to create new things very quickly. And we do create a lot of things, a lot of new things. And basically, it helps us to be agile. That's it. Thank you.